Hey, so in this video what we're going to do is we're going to watch as our computer learns to play the ViZDoom defend the center scenario. So in this scenario, the computer can only turn left or right and fire, and then enemies come from all around it. So it has to learn to turn to find the enemies and then shoot those enemies. It has a limited supply of ammunition. Once it runs out of ammunition, it can't kill enemies anymore. So we're going to train this for 75 hours, which costs about $25 on an Amazon instance. And then every 10,000 episodes, which is about 5 hours of training time, more or less, we're going to make a copy of the model as it is. And what we're doing here is we're playing back. We're taking each of those models and we're making it play one episode and seeing how it looks. So we're going to look at the model after 0 hours, after 5 hours, and so on for the rest of the training time. So let's begin. All right, so this is right at the start, and so initially it's just playing randomly, and then here after 5 hours it's learned, okay, I should turn and shoot. I mean, it's turning a lot, and it's not shooting very accurately. Here it's learning to shoot a little bit more sparsely, maybe. So we're now up to 30,000 episodes. It's been training for 17 hours. It's cost about $7. So it's getting a reward of like 2. So it gets a reward of +1 every time it shoots a monster. It's still on 2. And basically what it needs to learn to do is to kind of turn and then aim at the monsters and then shoot them. It's learning all this by itself. Like, it doesn't actually know what it's doing. What it does is the network has what we see on the screen is the input. This goes into a convolutional neural network, and then the output of this network is the decision. Should I go left? Should I turn right? Or should I click fire? But it doesn't know that any of these buttons actually means left or right fire. All it knows is what it can see happening on the screen. Right, so now we're up to 45 hours, which is about 2 days. It got a reward of 12. It's actually learning to save ammunition, and it's learning to fire basically when there's a monster in front of it, more or less. But it's kind of missing a lot, so it kind of vaguely shoots them. It actually is getting quite a few. So we're up to a reward of 6 now. We're on episode 100,000. It's been training for 2.5 days. So it's not doing badly. It could be a little bit more accurate. What's happening here is it ran out of ammunition, so it couldn't do anything. All it could do is watch as the monster killed it. So now we're up to 62 hours, and it's gradually becoming more accurate. And then out of ammunition. What it needs to learn to do is to conserve its ammunition and shoot accurately. So it's shooting fairly accurately, but it could be a little bit more accurate. I think it's doing a fairly good job at conserving ammunition. Like, it's realizing that it shouldn't be shooting when there's not a monster in front of it. And now we're up to 67 hours out of ammunition. And this is the second to last episode. This is about as good as it gets. So it's getting rewards of about 21. It's shooting 21 monsters before it dies, which is not bad. I mean, it's pretty good. Yeah, and then out of ammunition. And then this is the last episode. So there's sort of some variance in the game. So this particular episode, I think this is not its best game. I think the second to last game was its best game. So unfortunately at this point the game crashed on my instance. So there's no more training. I think if we carried on training for another couple of days, it would have likely become a little bit more accurate. But there we go. So this is using the reinforced algorithm, otherwise called policy gradients. There are other better algorithms called PPO. This is a relatively straightforward algorithm to implement. If you're interested in reinforcement learning and you're interested in building this system yourself, I have some videos in my playlist where I build this system from scratch. So maybe I'll see you there.